In 8.5, we're going to be adding and subtracting rational expressions. So again, rational being at the root word ratio, so we're using problems that have division in them. And remember, when you're adding fractions, you have to have a common denominator. Now, if the problem starts out, if you're lucky, and frankly you never will be, but if you're lucky and you have a common denominator already, then we just add the tops of the fractions and we leave the common denominator alone. It already has a common denominator. Now in this case, we get 10 over 4x. And at the end of the problem, if you can reduce, you should. So I know that 2 goes into 10 and goes into 4, so I would reduce this to 5 over 2x. And that would be my final answer. Now, if I wanted to verify that the original problem was indeed the same as my final answer, remember you can do that with your graphing calculator by going to your y equals, plugging in the original problem, so 7 divided by, I've got to put parentheses around the 4x, plus 3 divided by 4x. And in my y2, I'm going to put my answer, 5 divided by 2x. Okay. And then if I go to my table, I should see that the y values are identical at every single y value. And if I hit graph, I'm going to hit zoom 6, so it just goes a standard window, I should only see one graph. So it traces the first graph, and then it's still thinking because it's tracing over that second graph again. So sure enough, these two things really are equal. It gets a little bit trickier, and you guys will know this from adding fractions, when we have not or unlike denominators. So for example 2, which by the way is actually example 3 in the textbook, we've got 7 over 9x squared plus x over 3x squared plus 3x. In this case, I have not like denominators, and so I'm going to need to get a common denominator as my first step. Now to do that, to see what I need in common here, I'm going to need to factor. So I'm going to break this down as 7 over 9x squared plus x over, and now here I see that I've got a 3x I can take out. When I do that, I'm going to be left with x plus 1. I can check this because 3x times x is 3x squared, and 3x times 1 is 3x. Now I ask myself, what is my common denominator going to be? Well, I have to have the biggest thing that both of these denominators go into, or the smallest thing, sorry, that they both go into. So for instance, between 3 and 9 both go into 9. So I need my common denominator to have a 9 in it on both sides. Now to do that, I have to multiply this 3 by 3. So I'm going to multiply top and bottom of this parenthesis by 3, because 3 times 3 is going to give me a 9 down there. I also need an x squared, so I'm going to write x squared here. Now this already has an x squared, but this right now just has a plain x out in front. So I'm going to have to multiply by x on top and on bottom. Okay, that's going to give me my 9x squared. Finally, this guy over here has an x plus 1, and this one doesn't. So I'm going to have to multiply top and bottom by x plus 1 so that both sides of my fractions, both fractions have x plus 1 in the bottom. So now they both have what the other one had. Okay, we have this entire group. We have a 9 in both, we have an x squared in both, and we have an x plus 1 in both. Since I've multiplied top and bottom by some things, now I've got to do a little bit of math. For instance, on top of this fraction, I have 7 times x, which is 7x, and 7 times 1 is 1. On this fraction, 3x times x is 3x squared, because x times x is x squared. And now, since I have a common denominator, I can rewrite the bottom as just one fraction, and I'm going to add the tops of my fractions just like I did on the problem above. So 3x squared, well, I don't have any like terms, so I'm going to put 3x squared here, plus 7x, plus 1. It is really tempting in a problem like this to start canceling now. You guys are going to really want to start canceling your x squareds out. If you check your answer in your calculator, though, you'll see that it doesn't work. So make sure at the end of every problem, just like we did in the problem before, you plug the original in as y1 and the ending equation as y2, and make sure that those two things are equal, because that'll tell you if you've gone too far and crossed out things that you're not supposed to. So I'm going to put a little note here, check your work, because it's really, really easy on problems like this to do something that you're not supposed to. So this would be my final answer. I'm not going to cancel anything. I'm not going to reduce anything. This is the final answer of those two fractions added together. Check the next video for subtraction, please.